Problem 85. Determine whether or not Rolle's theorem applies to the given function on the interval -2 to 2, and find any values of c guaranteed by Rolle's theorem. So first, recall that Rolle's theorem says that if, first, f is continuous on the interval a to b, and f is differentiable on the open interval a to b, and the function evaluated at the endpoints agree, so f of a equals f of b, then we can find some number c in the open interval a to b so that f prime of c equals 0. So let's apply this test on each of these three functions. So for part A, f of x equals 1 over x squared. First, we want to ask, is f of x continuous on the interval -2 to 2? And if we look at this, at x equals 0, the function is undefined. So since it's undefined, it's not continuous at 0, so it's not continuous on this interval. Since it's not continuous, that says the first point of Rolle's theorem doesn't hold. So that says Rolle's theorem does not apply. For part B, first we want to know, is g of x continuous on the interval -2 to 2? And g of x is a polynomial, so yes, it is continuous. We look at the second part, is g differentiable? And again, g of x is a polynomial, so it's differentiable at every number, including the interval -2 to 2. And then finally, is g of -2 the same thing as g of 2? We plug -2 into the function g of x, and this gives us 4 plus 2 plus 1. We plug +2, we have 4 minus 2 plus 1. And this says 7 is equal to 3, and this is not true. So since the third point in Rolle's theorem doesn't hold, we say that no, Rolle's theorem does not apply. Part C. We'll ask the same three questions. First, is h continuous on the interval? And it's a polynomial, so yes, h is continuous. We ask the second question, is h differentiable on the interval -2 to 2? And since it is a polynomial, yes, it's differentiable. And third, is h of -2 equal to h of 2? Do the endpoints agree? We plug -2 into this function, and this gives us 4 minus 3. We plug +2 into this function, we've got 4 minus 3. So this is 1 equals 1, and yes, we have that h of -2 equals h of 2, so Rolle's theorem does apply. Now to find the value of c guaranteed by Rolle's theorem, we need to set h prime of c equal to 0. That means we need to set the derivative of our function, which is 2x. We need to set that equal to 0, and then solve for c. We divide both sides by 2 and get c equals 0. So we found the value of c guaranteed by Rolle's theorem.